Well, hello everybody. Today I'm gonna talk about HbbTV and describe what is HbbTV, what you have to take in notice when you want to handle HbbTV layer for some TV stations, what architecture decision it brings. And at the end, I will talk about UWSGI web server, as I has last year a presentation about UWSGI in general. Today I will show how to solve real problems and real things with UWSGI. So, HbbTV. HbbTV is a layer on top of digital broadcast of terrestrial, satellite or cable TV distribution. And HbbTV defines some special events, special packets in the primary video stream that says to the TV, to the client, hey, there's an app, you should run this app and overlay it over the standard broadcast. Those apps are written in HTML, CSS, and so on. And in those TVs, there are many JavaScript APIs to get information from the television, to plan some events in the stream, and so on and so on. The standard is here from, let's say, 2012 or something like that. Many of the televisions support it, but not so many televisions are connected to the internet. Problem with the TVs is let's say every customer buys TV deciding on the screen size, on the color quality, on the sound quality, but no one takes in a notice quality of the internal browser of standards it supports and so on. So the landmark of, let's say, the quality of those browsers is really poor. What is HbbTV good for? Well, you may know services like Prima Play or Red Button or e-vysílání from Czech television. All of the things are HbbTV services signaled on top of the basic broadcast. And every TV station has some server, some component, which solves the application announcement, the basic application running. And today I'm gonna talk about these, let's say, ad servers or servers handling the basic applications in the DVB, TS or C streams. Requirements. So what are requirements for application like this, for a server like this? If you are commercial television, you really care about advertisement targeting. When you have advertisement, you want some capping. You want to have some simultaneous campaign, some analytics. You want to know who is watching those channels and want to know which advertisements were served and so on. And you really have to care about reaction times because there are some limitations, like you can't show HbbTV advertisement when there's advertisement spot for some other products and so on. The big problem with reaction time and synchronization is there's a big difference in the timeout or in the time when the signal meets the television. For example, when you are receiving from DVB-T, like classic terrestrial television, or DVB-S, through satellite, there may be, let's say, 10-15 second difference. The requirements, when we were defining the requirements for such a service, we had to find out what are the problems it has to handle. Different stream time, great number of connections, how many users or viewers, like a combination of viewer and user, we call them viewers, and so on and so on. So we wanted to have bulletproof architecture with high availability, with taking care of performance. From the beginning, we were working with the thought that there will be many parallel requests and many simultaneously opened connections, but with low network traffic and various latency. So, what is the architecture of service like that? Number of advertisements should not affect performance. Logging analytics should not affect performance as well. Handle as many clients as possible with minimum latency and minimum hardware requirements, and some basic stuff for ad servers out there. We were looking for a solution with minimum or no I/O operation, just not to wait for a network, not to wait for writing to disk and so on. To serve everything from memory. At the beginning, we were planning to use the WebSocket massively, but from the first testing in field, or in production, let's say, we have found out that the buggy browsers in those TVs and old browsers, there's only 40% support for WebSocket, so everything has to be just HTTP request or a request with long polling. And we have decided not to use some middleware like Flask or CherryPy or Django or something like that. So we have built everything on a UWSGI or a UWSGI. So from now on, it will not be variation for my presentation for last year. It will be more like examples of how to use UWSGI for such a problem. So, what modules or features of UWSGI we have used? It's mules, queues, caches, and Gevent with WebSocket. Mules, we are using then just mule is just a code or script that runs in the UWSGI environment. You have the loop and you handle the logic. You can communicate with the rest of the application through queues, caches, and other shared memory objects UWSGI provides. Why mules? Because we can offload loading, targeting space. We can offload capping. We can offload logging, and so on. So when at the time of request or event on WebSocket, every data goes from memory. And there's no need to wait for disk, for network, for anything else. And it's perfectly fine to have everything cached in a memory or queued for logging. Offloading such a request, such a thing is very easy. It's a few basic lines of code. You just enable queue in configuration and use it like any other queue from standard library or queue in a Redis or RabbitMQ. The principles are the same. The queues in UWSGI are just simple or simplest to the bottom. You just queue some strings, and on the other side, the strings you can read them. Cache. Again, the simplest cache possible. You can set key value with expiration. Everything is stored in memory. You can pick two algorithms for key hashing and so on, but it just works with local memory. It's like Redis or Memcache or without network. You don't have to wait for network even on a local host. Everything is string, key is string, value is string. If you want to store any complicated type, you have to handle serialization or deserialization on your own. You can define expire. UWSGI supports node or cache synchronization between nodes, but it's done via UDP. So if you have those nodes in distant networks or do data centers, it's not good. Low-level WebSocket interface with Gevent is well, it's implemented in UWSGI. You can use it. Just by completing the handshake and communicating with the socket, and then handle events or communication with this application. And that's all. I thought that everyone will be hungry before lunch, so I didn't want to make it long, and I wanted more time for questions because the HbbTV and the whole television world is not so well known. So ask me for anything. The world of linear broadcasting and internets are very different, and HbbTV is a standard which is trying to bring or to glue those two worlds together.
Okay, thank you. One question on Slido. Why did you decide not to use Flask, Tornado, etc.?
Well, Flask, Tornado, well, I'll start with Flask. I didn't figure out why to have some code that is not necessary in the application. So for a problem like that, when you handle two paths in URLs and socket, WebSocket, you just don't need thousands of lines of codes to, with a regular expression to handle some path and decorators and so on. So there was no need. And the question to the Tornado, well, UWSGI is internally working asynchronous, and even with enabling Gevent support for better WebSocket switching, there's no need to use any other asynchronous framework. UWSGI handles everything, and it just works fine. So Just less code gives you more performance, and less code gives you less code to debug.
Okay, thank you. We have a new question from Anonymous. What traffic are we talking about? QPS?
Well, I don't know what's QPS.
Is here an anonymous author who would be...
Your queries per second. Well, I don't know the latest stats because we are handling some small specific TV stations like Kinosvět, Rebel, Relax, and so on, just the long-tail TVs. There are some hundreds of thousands of viewers at the same time. So it's just about planning the refresh rate of the application on the screen and planning and communicating via WebSocket. In the case of WebSocket, we can handle 10 of thousands open connections, and it doesn't matter.
Okay, thank you. And one more question. Can you deploy new versions of the backend code without losing cache and or WebSocket connections?
No. No, and it's we don't need to. The cache and targeting space is refreshing periodically, let's say every minute. So when we deploy next instance, it just loads the targeting space and capping parameters from backend and working from memory and refreshing. So we don't need to. About WebSocket connections, yes, that would be fine. If the connections survive, let's say, node restart, but we didn't solve it yet.
Okay, thank you.